Hi everyone! In this video we are replicating one of my works that I shared on social media a while ago. The tutorial will be divided in 3 parts. First, we'll create visuals that respond to the mouse. You will make them by the end of this video if you follow till the end. In the second part, we'll connect the LiDAR. I'll show you which one I used, how I connected it to TouchDesigner, and share some tips for optimization. Third, we'll connect LiDAR data to the visuals and adapt them to respond to multiple touches. First, let's separate the technical and the visual parts in advance. Add a base component and name it LiDAR. We'll come back to it in the second part. Then create a container component and name it Visuals. Go inside. Open the palette and find the Particles GPU component under the Tools tab. Drag it to your network. By default, it creates a 3D particle scene, so let's adjust some parameters. Change the material to lion for now. In the Particle Source tab, adjust the parameters to spread particles across the flat rectangle. Particles GPU already has an internal camera which you can control by clicking the icon in the bottom right corner and navigating with the mouse. It's very convenient when sketching on the go, but when I need more precise control, I add an external camera. Deactivate the viewer and drag the new camera component onto the Particles GPU. Here I go to the View tab and set the projection to orthographic. Increase the width. To make the workflow smoother later on, I'll set up the particle system to refresh using a keyboard shortcut. To get the image from the component, add a null and RGB key top to fill the background and a node top. Add a constant drop. Name it resolution and set the width and height of your final render there. Link these resolution values to the Particles GPU. I recommend doing this even if you're working with the default resolution, because it's always better to define resolution in one place for easier adjustments later on. Next, let's zoom out and set the same resolution in the container. To set the resolution that we defined inside this container, we need to type the following script. / means that the operator under the name resolution is located inside the component. Repeat for the height. In the Look tab, refer to the name of the operator inside the component you want to display. Inside the container, divide the screen into 3 sections. Choose Display panel in one of the right sections. I display visuals as panel when I do something interactive because it allows to take coordinates only within this panel, but not from the whole working area. And for mouse coordinates, I'll use a panel chop. It has a lot of values, but we need just 2 of them. Select inside U and inside V. Create a null and call it mouse coordinates. In this project, I'm combining 2 techniques to make the visuals interactive. The first one is Optical Flow, but before we add that, we need some object or shape that moves around and affects the particles. Add a circle top. And make its radius smaller, something around 0.15. In a Circles Common tab, we need to define the resolution. Do it the same way we've done with Particles GPU. Okay, the circle was too big. Next, connect your mouse coordinates to the center of the circle. And something is off. That's because mouse coordinates are in UV space, while the circle's position is in screen space. So we just need to remap the values. Add a math chop and remap the values in the Range tab. Since we are in screen space, I'll add a rename chop and rename the channels to TX and TY. We also have to rename them in the circle top. Alright, now the circle follows the mouse, so it's time to add an Optical Flow component. It's in the palette right above the Particles GPU. Optical Flow creates a motion field based on changes in brightness of an input top. You'll get a better sense of that when we connect the components. In the Optical Flow, set the force parameter to 3 and offset to 50 to make the effect more visible. Now go to the Particles GPU component, open the Forces tab and look for the Optical Flow size remap parameter. You will need to remap it to fit the effect to your screen size. That's not enough, so I'll multiply the values until the visual result looks right. Alright, I want to slightly change the feel of the movement. Let's look at the circle. As I previously mentioned, the Optical Flow calculates movement based on brightness of an input. So if I blur the edges, which is called softness here, it will affect the animation. Select the Particles GPU component and go to the Forces tab. We'll need a turbulence noise here set to a very small value, just enough to add more life to it. Next, I want some swirl movement around tracked areas, and to do that I need to use an extra force. There are a few additional forces available in this particle component, and to find them we have to go inside the component and find the null extra operator. Well, that's obviously a null, and the previous one is an actual operator that sets extra forces. I'll copy it and paste next to the particle's GPU. Delete the script over here, rename the operator and attach it to particle's GPU instead of null extra. Now let's increase the force amount to 1 and switch the force type to 2, which gives the swirl movement. Attach your mouse coordinates to the first two parameters. This doesn't work properly because forces are in another coordinate space. But that's not a problem, we just need to rename the values again, this time separately for x and y. Add a select chop right after the math. Here I'll choose the tx, then duplicate the operator and choose ty. Add another math chop. And in the range tab, set the values from minus 0.5 to 0.5. Copy the math and connect the ty select to it. Then connect the operators with the merge chop. Add a null and call it force coordinates. Reference it to the position in the extra force and remap two range values in the math chops until it looks correct. Now tweak the extra force operator again. I like to combine several forces. To do that, I'll duplicate this operator, combine them with the join chop, add a null, and let's name it forces. Attach it as extra forces in the particle's GPU and experiment. You may add even more forces if you like. Okay, now I can disable this forces wireframe. Let's go to the Material tab and choose the Custom Material. Create a constant material and reference it by dragging onto the particle component and choosing Custom Material option. Add a rectangle top and attach it to the material. In the constant material, go to the Common tab, enable blending and set the destination color to destination alpha. You may not see a big difference for now, but it will be more noticeable when we set colors. Now let's adjust some parameters in the particle's GPU. It took me a while to replicate it closely during recording, so I decided to speed up the process and leave here the parameters that I changed. Let's limit the maximum velocity to 3 to make the movement a bit more coherent. As for the colors, I'll make them driven by velocity. The color is set in render tab of the particle GPU component. We need to choose velocity lookup for color type parameter. And to modify the colors, we can attach the chop here, but I don't like using chops when setting colors because it's not intuitive. So I go inside the component and find the color lookup. I need top. So that's where the colors are being set. If you watched some of my other tutorials, you already know what to do. Create a ramp top. Set its resolution height to 1, and the width will define the number of colors or shades that is used. Connect this to the color lookup and set colors. When choosing the colors palette, I like to think about relationships between warm and cool tones. Here I loosely reference thermodynamics, where higher temperature means faster particle movement. This isn't an art and science project, but I think linking high speed to warm tones just feels right sometimes. We are almost ready. Now let's make some kind of trails. Go to the palette and find a feedback component there. Add it to your network. I didn't even change any parameters here. To add a pinch of glow, I will add a bloom top. And adjust it to make the effect slightly visible. Let's remove the vertical particle movement. Just delete the script. Also make another animation a bit slower. And that's it with the visual part. It's already ready to be connected to Orbic, Kinect, MediaPipe or anything like that, but we will switch to our LiDAR setup in the next part.